In video number 261, we began a journey to combine IoT sensors with our Raspberry Pi to monitor our environment. The process we want to watch is the fermentation of beer. Will we be successful? In the process, we will tear down one of the sensors and you will get some Fusion360 tricks. Grüezi YouTubers, here is the guy with a Swiss accent, with a new episode and fresh ideas around sensors and microcontrollers. In the last video, we were able to understand tire pressure sensors and also hack their protocol using an SDR radio. Today, we will continue towards our goal to get a gentle curve in Grafana and alert the brewer with his smartphone if the pressure is too high. Because if this happens, the bottles can explode and create a big mess. And it will not only be one bottle, as one of my viewers wrote. All bottles exploded, one after the other, when he was a child and he still vividly remembers that event. Most monitoring solutions look the same. Sensor, wireless communication, data storage, visualization, connection to an alarming system like email or Telegram. And this is precisely the way we will go. Fortunately, we already have a solid base. In video number 255, we built a Raspberry Pi image consisting of Node-RED, InfluxDB and Grafana. And in video number 261, we hacked the TPMS sensors. But first, what is the problem we want to solve? According to How to Brew, beer is brewed in these phases. Malted barley is soaked in hot water to release the malt sugars. The malt sugar solution is boiled with hops for seasoning. The solution is cooled and yeast is added to begin fermentation. The yeast ferments the sugars, releasing CO2 and ethyl alcohol. When the main fermentation is complete, the beer is bottled with a little bit of added sugar to provide the carbonation. Here, the refreshing CO2 is produced. For phase 1 to 4, you get sophisticated equipment and automation using Arduinos or Raspberries. We will not cover that part. Step number 5, however, is still a very conventional process. The normal pressure goes up to around 2 bar. If you made a mistake, much more pressure can be created. You find different solutions for the measurement of the pressure, also homemade ones. They are sometimes quite innovative, but none is electronic, none is wireless, and none is connected to a remote monitoring or alarm. In short, IoT did not arrive here in the deep cellars of the homebrewers. We want to change that. And this is the guy who came with the idea. Reto, the hop nerd. You find a link to his YouTube channel in the description. The conventional mechanical pressure sensors have a few disadvantages. They are expensive and hate water, because it is necessary to clean everything used in the fermentation process. You easily destroy these instruments. We do not want to change the underlying brewing process. It was invented by monkhood a long time ago. Their problem was that they had to fast during extended periods and therefore were always hungry. Because it was allowed to drink, they liquefied the grain to create a drink with lots of calories. These guys were really innovative when it came to improving their quality of life. Of course, we do not know if God accepted the trick after their death. Back to the bottles. I found cheap sensors on AliExpress which should fulfill our needs. We tried it out in the last video and now I want to take it apart to see what's inside. Not easy because it has to be airtight. But I do not spare any effort for my viewers. I have to admit, finally I discovered 3 hidden screws which would have made it easier. Shit happens. We find one big chip made by Infineon. It is a SP37, specially made for such TPMS systems. It has everything on board: pressure, acceleration, temperature and voltage sensors. An MCU, a 433 MHz transmitter, and a receiver for 125 kHz. The chip can send ASK or FSK signals and has to be programmed by the manufacturer of the sensor. This is why we see so many different protocols. The pressure and acceleration sensors are both so-called micro-electro-mechanical systems or MEMS sensors. MEMS sensors are made of silicon and can be integrated on the chip. This is why such a complex chip is so cheap, less than $2 in quantities of 100. And they are exact, plus minus 7 kilopascal, which is 0.07 bar. I'm sure this is way more precise than these mechanical instruments. Only very few additional elements are needed. Unfortunately, there is no space for a decent antenna for 433 MHz, so they only work at short distances. A coil to receive the 125 kHz signal is not implemented at all. These external sensors are mounted on a tire valve. In the last video, we found out that they only transmit if they detect pressure changes. This is precisely what we need, and I thought I just have to mount such a sensor on an empty bottle. This was a big mistake, as we will see. It took me many days and nights to discover that getting something watertight is much more straightforward than getting something airtight. My first idea was to use a bottle with a thread for the cap. I thought a thread is easy to manufacture and stable. Fortunately, I had this bottle of wine in the cellar which fulfilled my criteria. I have to confess that it was full and, in the name of science, I had to drink it before I was able to start. This was the first evening of many. This evening was nice, but not very productive, if you know what I mean. The next day I discovered that these wine bottles do not use a standard thread supported by Fusion360. So I had to learn to build a thread using a coil and some black magic. If you know how, you can create all sorts of threads with Fusion360. Google and YouTube help you to find a tutorial. In the end, it worked. I remembered that my brother is in the car tire business and he gave me a few of his valves for tubeless tires. The hole on the top of the bottle was big enough for the valve and I made a snugly fitting hole in my 3D printed cap. Now I used my bicycle tire pump to bring some pressure inside the bottle. I immediately discovered that the thread was leaking like hell. The first fail. Then I looked at how other people solved the issue and found these beer bottles with this ancient bugle cap. They have quite a revival here. So it was easy to get one. And you're right, you cannot buy them empty. But as a nerd, I knew how to solve that problem. Fortunately, a bottle of beer did not have the same devastating effect as the bottle of wine last night. Maybe it even fired my imagination. I printed a new cap which resembled the white part of the bugle cap and used the round red rubber sealing. And the first cap was tight. I was able to create pressure, mount my sensor, and the pressure remained a whole day. Then I showed my solution to brewer Reto. He was not amused. Real brewers do not use wine bottles. Their bottles either use this bugle or a crown cap. But for sure, no thread. So my whole work was down the drain and I had to start over. I thought that the principle of the bugle cap would work for me too and printed a hat which was very similar to the one I bought. I had to mount the valve above the cap and transfer the pressure to the valve. Because of this metal wire, I had to create pressure holes around it. Very cool if you have a 3D printer. At least this was what I thought when I was sitting in front of Fusion360. This concept had two parts, the cap and the holder for the valve. I glued the two together, first using superglue. Usually superglue is quite good with PLA. Unfortunately, this was the next failure. This glued joint leaked. Not a lot, but way too much for a decent brewer. The next fail. I tried with another glue. Same effect. I tried to add better surfaces. It did not help. This joint was not tight. Then I changed the strategy and added sealing paste. The brand was quite promising. Fix All. It is a very sticky material. This one was tight, but it also clogged the pressure holes. It really fixed all. Next failure. In the end, I was able to apply it with caution and I got an airtight version. Only to discover that the bottom of the cap also leaked. Because 3D printed surfaces never are entirely flat, air found its way out. I was desperate because I had no idea how to solve this problem. But I had promised a solution for Monday. Finally, after buying and emptying all sorts of beer bottles, I changed strategy entirely and went back to a standard thread. Because my beer bottles do not have threads, I had to create one. I took a picture of a bottle and inserted it using the canvas function. Then I calibrated its size. Now I had the model of the rather complicated bottleneck inside Fusion360. I started to sketch the contour using lines and the spline function. I measured the most critical point using my caliper and added a dimension to be sure. Now I only had to revolve the outline and ready was my sleeve. Tight like the jeans in the 70s. On the outside I added a thread. This is an incredibly cool Fusion360 function. You just select the surface and Fusion360 suggests you a thread. For 3D printing, we choose the loose fit. But how the hell can I mount this thread to the bottle? No chance from the bottom and no chance from the top. So I had to cut it in half. This is only one command in Fusion360. Now I have two bodies and I easily can mount them. But I wanted to add a little leeway. Another cool function helps here. Press pull. Just select the surface and choose the distance. Fusion360 does the rest. A miracle for me. The final part looked like that. It was easy to mount and my bottle had a thread. I only had to use my cap idea from the beginning of the project. Now it started to become at least a little fun. Also because I was now officially allowed to drink beer in my lab. I told my wife that I need empty bottles for my experiments. After printing the cap, I discovered that the opening of the beer bottles is much smaller than the ones of the wine bottles. The valve did no more enter the bottleneck, and the wine bottle principle did no more work. Again, I was not amused and went to bed. As usual, important discoveries are made by Mr. Coincidence. When my colleague came to discuss our bicycle trip along the Danube River, I showed him my newest designs to complain about how I miserably failed. I tightened the hat with the valve hard because I was angry about my failure. When I removed the cap, the valve was sitting extremely tight in the opening. A quick test showed that it was also airtight up to 3 bar. I did not want to go higher to avoid an explosion. So the solution was way simpler than I thought. Just press the rubber of the valve on the opening of the bottle. Done. Now you can write in the comments that I'm stupid and you saw this simple solution right at the beginning. I have to believe you, because all simple solutions are apparent when they are discovered. Reto was ready with his beer, and I visited him in his lab in the basement. I have to admit, my lab looks nicer. But the products Reto produces taste much better than mine. He already filled the whole batch and left the amount of beer for 2 bottles. We filled them without forgetting to pour a little sugar into the bottle first. Then he closed one bottle with my sensor and the other one with his mechanical pressure sensors for comparison. In the beginning, no pressure was shown on both sensors because it does not increase fast. So we had enough time to drink one of his tasty IPA beers. My absolute favorite.
Probieren das mal aus, ich hoffe. Ja, das zischt schon.
Ja, super.
Oh, das hat schon fast zu viel.
Next morning, I got a mail with the pictures of both displays. My solution worked and showed a very similar value. He will now test the sensors during the next weeks, and I will develop a robust infrastructure for the Raspberry Pi. And I hope I'm ready with my design when the beer is ready to drink. Because the 2 test bottles have to be consumed that day when we remove the sensors. We still have to go a long way till our software-defined radio works on a Pi Zero, is hardened that it survives all kind of crashes, reports the results into InfluxDB and Grafana, and alerts us via mail or telegram. Stay tuned, because this video will be precious for all types of projects. I hope this video was useful or at least interesting for you. If true, please consider supporting the channel to secure its future existence. You find the links in the description. Thank you. Bye.